Perhaps the most famous recursive sequence is the Fibonacci sequence. Fibonacci was a mathematician called Leonardo of Pisa, and I think he was called Fibonacci because his father's name was Bonacci. So he said, imagine that you have one mating pair of rabbits, and this mating pair of rabbits in the second month of their life can produce another new mating pair of rabbits and can produce one more mating pair of rabbits for every month thereafter. So I'll just write that down. So imagine these rabbits. They can produce one new mating pair starting in month 2. And then they can produce one new mating pair every month after that. Okay, so let's keep track of the rabbits. Okay, so at the very beginning, month 0, we have one new mating pair of rabbits, and at the beginning of month 1, we still have one mating pair of rabbits. So there. Okay. So one pair. And then in month 2, we have the original pair of rabbits. But at the end of the second month, they were able to reproduce and create a new mating pair of rabbits. There we go. We now have 2 mating pairs of rabbits. Okay, so at the beginning we had 0, 0 to 1, okay, 1 to 2, 2 to 3, 3 to 4, so we'll call this month 3. We still have the original pair of rabbits, and we also have the new breeding pair that was created in the previous month. But in the previous month, the original breeding pair of rabbits also created another breeding pair of rabbits. There we go. Okay, so starting from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, so we'll call this month 4 at the very beginning, and we have the original pair of rabbits, we have the first pair of rabbits that they produced, we have the second pair of rabbits that they produced, but now we have, in the month previous, this pair of rabbits was still able to produce a new pair, so we have a 4th breeding pair of rabbits, and the first pair they ever produced is still able to produce a new pair, so we have a 5th breeding pair of rabbits. Okay, we could keep going, but I think we would run out of room for bunnies. In the next month, these ones will be able to produce a pair of bunnies. these ones will be able to produce a pair of bunnies, and these ones will be able to produce a pair of bunnies, plus you'll have the 5 pairs of bunnies that you see here. So you'll have 8 pairs of bunnies. So I'm going to create a table of values to represent the situation here, and I wasn't sure whether to start at 0 or 1. Both make sense. I think we've been starting at 0, so I'll continue that. But you could easily shift things along so that it would be like month 1, 2, 3, 4, 5. That would also be fine. I think it depends whether you're talking about the month when you begin or the month at the end of the generation. Okay, well, I suppose not exactly a generation, but for a rabbit, I guess it is. Okay, 1, 2, 3, 4, 5, 6. Oh, pardon me, that's month. Okay, 1, 2, 3, 4. So in this month we had 1 pair of rabbits, and this month we had 1 pair of rabbits, and the next month we had 2 pairs of rabbits, and the following month we had 3 pairs of rabbits, and then we had 5 pairs of rabbits. And I think you remember me saying that we were going to have 8 pairs of rabbits after that. So what numbers would you write for the output for the next 2 months? If you guessed 13 and 21, you'd be correct. So this recursive sequence specifies that any term in the sequence is the sum of the 2 previous terms. Pardon me, and minus 1, okay, plus term n minus 2. Okay, so term n, any term, is equal to term n minus 1 plus term n minus 2. So for example, term 21 is equal to 13 plus 8. Okay, and that works for all of the terms here. This sequence shows up in nature in many different places. Some examples are the number of seeds in the head of a sunflower, the number of bumps on the surface of a pine cone. They're usually a spiral pattern associated with those. The shape of a nautilus shell, and many other places.